Welcome to a new video of soil, water and weather for this 683. In this case the topic is porosity. Porosity is an important soil physical property that is related to several other variables. Among the most important ones we can cite soil moisture and aeration. A useful relationship to keep in mind at the time of solving for porosity is the following. Porosity, when expressed as a fraction, is represented by the letter F and is equal to 1 minus the bulk density, represented by the Greek letter rho and the subscript b, divided by the particle density, again represented by the Greek letter rho and the subscript s. Let's start proving this relationship by stating that the total volume is equal to the volume of voids plus the volume of solids. If we then divide each term of this equation by the total volume, we get the following two expressions. Something interesting in this step is that the volume of voids right here divided by the total volume is equal to porosity. Typically we know what is the total volume of our soil sample, but we generally don't know what is the volume of the solids. Since we are also solving for porosity, that means that we have two unknowns and only one equation. Therefore, we cannot solve this unless we find a different way of expressing the volume of the solids. Nicely, and I hope that you remember, density is the bridge between mass and volume. Therefore, we can express the volume of the solids as mass of solids divided by the particle density. If we substitute this relationship into our expression, we get the following, and then if we simplify, we can actually have a much simpler expression. In step 6, it is interesting to notice that the mass of solids divided by the total volume is equal to the definition of bulk density. Also, it is interesting to notice that we can rearrange this formula here and we get the following. We get particle density equals to mass of solids divided by the volume of solids. Now, if we compare particle density and bulk density, we see that the only difference is actually in the denominator. So keep in mind at the time of calculation to not get confused with particle density and bulk density. If we keep going with our proof, we see that we are now very close to our original expression, and actually if we rearrange the terms here, we can get the initial relationship. Like this, we have proved that porosity equals 1 minus the bulk density divided by the particle density, and I want you not only to remember this last expression, which will be very useful for calculating porosity, but also the definition of particle density and bulk density right here. Thank you.